This video is taking the piecewise function we have here. So this is the first rule and the first interval we're going to graph it over, and this is the second rule and the second interval we're going to graph it over. We're going to take this piecewise function and we're going to plot it on this graph. So the graph goes from -5 to 5 on the x-axis and from -1 to 3 on the y-axis. And I did that because I already know which spaces it's actually going to take up, and I don't want to waste any room on the board. So the first thing we have to look at is where we're going to graph each section. So I'm just going to draw little lines under here to represent which parts of the domain are going to be covered by this and which parts are going to be covered by this. So this function f of x equals 1, that's if x is less than 0. And it doesn't include the point 0, it's x is less than 0. So we're going to do an open circle at 0, and it's going to go on forever this way. So this isn't the line, this is just where we're using this function. Then when we get to 0, starting at 0 and for everything bigger than 0, we're going to graph this function. So this function will start here with a filled in circle because it includes 0, and that will go on to infinity in the positive direction. So now what we have to do is graph these two functions over these intervals. This first function is just f of x equals 1. So we're going to graph f of x equals 1 over the interval from -infinity to right up to 0. But with the parentheses showing that it doesn't include 0. And then we're going to graph this equation, f of x equals x plus 1. F of x equals x plus 1 over the interval starting at 0 and going up to infinity. So starting and including 0, so square bracket, 0 to infinity. Okay. F of x equals 1 is just, remember f of x is y, so no matter what x is, y is going to equal 1. For any input x, the output will be 1. So if we were just graphing f of x equals 1, it would be a horizontal line from -infinity right through 1 here on the y-axis and right on to positive infinity. But we only want to graph it over this area. So I'm going to start here and go to here. I'm going to do an open circle because it doesn't include this point x equals 0. So an open circle here. And it does go on forever in this direction. So I just graphed this part of the equation. Remember, these aren't part of the graph, these two lines at the bottom. This is just to help you understand why I'm just graphing this piece on this side and why I'm graphing this piece over here. So this is just to help you see the domains. Okay, the next piece here is x plus 1, and starting at x equals 0 and going on to infinity in the positive direction, we are going to graph the function f of x equals x plus 1. F of x equals x plus 1 is like the equation of a line, so if it's y equals 1x plus 1, so the 1 was there but I just showed it because this 1 is our slope. That means rise over run equals 1. So every time we go up 1, every time we rise 1, we go over 1. If it was -1, we would go down 1 over 1, but it's positive 1. And then this one here, remember the equation of a line is y equals mx plus b, where m is our slope and b is the y-intercept. So the y-intercept is where the line intersects the y-axis. So the y-intercept will be 1 here. So right there. And then we have a line that's going to go up 1 over 1, up 1 over 1 with a slope of 1. So we'll go from 0, 1 up to 1, 2, then up to 2, 3, and it'll keep going like that forever. So here we have graphed this piecewise function. This is the graph. This I will erase. This part down here is just to help you understand the intervals over which each piece was being graphed. So these lines were just a way to show this information here. This isn't part of the work. This, again, is just to help you understand what we're graphing where. So this is your answer here, this graph.